Hello. So that you will understand what this video is about, we have asked some learners to draw a graph from the June 2018 physics paper. And the problem involves two stones thrown from a height. So here is the height. Stone A is simply dropped from rest, and after 2 seconds, stone B is thrown downwards at 30 meters per second. So they are asked to draw the graph of the two stones. So stone A is simply going to be a normal velocity time graph sloping this way. They've all chosen to have down as negative, up as positive. And the trick is going to be to see whether they realize you've got to wait the 2 seconds. So for the first 2 seconds, stone B is going to have zero velocity, and then it's suddenly going to have a downward velocity of minus 30 because down is negative. And then after that, it's going to have the usual slope. So the two graphs should end up eventually being parallel to each other. So this is the first time they're drawing graphs, and the most important thing is to see whether they get all the usual good stuff. So if they're going to be drawing graphs, they're going to have to, let's just suppose, they're going to have the heading. So we want a mark for the heading. They're going to have 2 zeros. That will get them a mark. They're going to have time in seconds on that axis. They're going to have velocity in meters per second on that axis. And then since everything is negative, they're going to have to do minus 10, minus 20, etc. Going down, minus 30. Now it's amazing the number of ways that one can get a graph wrong the first time one does it. And then on this axis, they've got their naught. They're going to have 1 second, 2 seconds, 3 seconds, and 4 seconds. The problem only goes up to 4 seconds. And then we're giving them this piece of graph paper to do it on. And this is what the problem originally looked like when it was presented. No pictures, nothing. Just reads as follows. A man drops stone A from rest of a high cliff. 2 seconds later, he throws stone B downwards from the same height with a velocity of 30 meters per second. The two stones hit the ground at the same time, ignore the effects of air resistance, and then they draw the graphs of that. So basically, this is, and so they've already worked out many of the values. They've worked out the height of the cliff and so on. So now they've come to question 4.4, which is on the same set of axes to draw the graph. So that is what you will see in the rest of this video.
Question?
How do you draw the graph if the velocity is zero? Potentially there.
So you started at minus 10, minus 20, minus 30, 40, so. How do you think you could get a zero in there?
I don't know.
What comes below minus 10?
Minus 20.
Minus 20, and what comes above minus
Oh, I
10?
see. Okay. Thank you, sir.
So reverse, so
No, it
that's the way my
must.
measurement is going, like that's the negative going down, that's the positive going up.
So you're doing yours
Negative
with
down,
negative down,
positive going up.
up.
Is it right?
Well, I'm not going to say, but if it works for you, that's fantastic. They've decided to make just negatives. Hi, Mr. Yankee. Good, thanks. Were you doing taking some sport? Were you doing some sport outside? You don't have a key to, and I can just hang it there. Thanks so much.
I'm gonna lock it by the corner.
You're going to lock it to the thing. Great. So it's question 4.4, which we did yesterday, Anneli, and then you're going to do a graph of it.
So are you doing work tomorrow?
I'm planning to. Is it okay? Are you coming tomorrow?
Most teachers said they're only working until Wednesday, so I was planning to not come tomorrow. And most of us were planning.
And what is the time now? Does anyone have the time? It's 10 to.
It's 10 to 12, so I really want to.
You know what? If you guys are prepared to work till 1:30, then we'll quit tomorrow. How's that?
Yes, sir.
And what about Miss Charles? She wanted us today.
Did she want you?
Probably make it till 1 o'clock, so and we can get math for that last hour.
Okay.
School, Ramadan.
So we got an hour and a bit.
We got an hour and 15 minutes.
Okay, we'll just make do of that.
Fine, sir.
That's fine. Okay, we'll just have to work super efficiently.
En wil sy Peter op.
I'll say Petrol, thanks for thinking of me.
Wat apa ya deh? Ini. Story respect. Ini one for 2 seconds.
Wow, you are good.
You showed me yesterday that.
Okay, but still you're good.
Kan tu tu sendiri. Cuma dia nak address dan dia kalau betul. Itu cuma dia só for 2 seconds. Só isso, só conta. Amém. Kalau zero six address, dia ambil code.
Hi guys. Wait, you just grab a piece of graph paper. We're drawing an accurate graph of 4.4 of the June 2018 paper. We're going to finish today because I believe you need to do maths, so we're going to finish just at 1 o'clock. I believe your teacher wants to do some maths later on, so we'll finish at 1. We've got an hour. So your one started at 13, and did it get minus 30, minus 40, minus 50, or did it get 30, minus 20, minus 10? What do you think?
I don't know.
76.
Okay.
74. It was 76.
First of all, we chose up as positive, down as negative. So the first stone, let's just have a look at stone A, which is stone A and which is stone B. Stone A started at 0, and then after 1 second, it was going up or down.
It was going down, so down.
It was going down, and down was negative. So it started
should be negative.
at 0, and then it went down. So if you're going to have on this axis your time, that's going to be 1 second, say 2 seconds, 3 seconds, 4 seconds, or you could have 1 second, 2 seconds, 3 seconds, 4 seconds. Spread it out. So you've got, that's the first plot is totally correct at 0.
Was 0, no?
But then what will it be after 1 second? It'll be 10 and it'll be negative 10. And that's what your second plot's got to be. But actually negative 9,8. Do you understand that or not? Okay. So, according to your Cartesian plane, it's much easier if you have your positives on top and your negatives. So change your axis to have, in fact, nothing is positive in this problem, everything is negative. So just have your Cartesian plane with maybe straight line there, make each of those 1, and then go 0, minus 10, minus 20, minus 30 or so, and then positive.
Now I regret why I didn't go.
I think you may. So you guys chose, you see you've done exactly what you asked, right, Michelle? Should you draw your graph with positive on top, negative like that, and so you drew it. And so that is the easiest way to do it. Now let's see if you're correct. So here is stone A, is it? And then after 1 second, it's going minus 10, after minus 20, minus 30, right? And so where's your seconds on this axis? You must put 1 second, 2 seconds, 3 seconds, 4 seconds.
So what is the 1 and the 1,5? No, it's too long. It's just semantics.
So you're nearly 100% correct, except you've got to do it 9,8, so it's not quite 10. You see what I mean? So you're going to just make it, so you must put your seconds, 1, 2, 3, 4, 5. It only goes up to 4. So you could even spread it out. You could have it 0, 1, 2, 3, 4. So you get a bigger graph. And then all of this is nice. But here's the thing that I must ask you guys, and this is where you must think. So stone A is just about right. Now, did stone B start moving at the beginning of the problem?
Yes, sir.
Stone B immediately started moving. Now think of the problem. Stone A was dropped. It fell for 2 seconds. It was just dropped. It fell for 2 seconds. In those 2 seconds, what was stone B doing?
Going down.
Had stone B started yet?
No, sir.
Stone B hadn't started yet. Make sense? So what is stone B's velocity if it hasn't started?
0.
So for the first 2 seconds, stone B wasn't doing anything. Then it suddenly went to what's velocity downwards?
Minus 30.
There you go. So your graph's got to reflect stone A started immediately, but stone B waited. And then it was suddenly went to 30. So what was, exactly. Something like that. Make sense? Jamie, does that make sense?
No, sir.
Okay. So you need to get a graph of axes somewhat like this. Okay? In fact, you don't even need the positives because everything is negative. You can choose it that size, not a problem. And then you've got your stone. Now, do you want to draw your stone A, but accurately at 9.8? So after 1 second, minus 9.8. There's minus 10, minus 20, minus 30. So just draw it accurately and then get your stone A. So you're going to have your graph, velocity there. It's going to go 0, 10, minus 10, minus 20, minus 30, minus 40. On
So I
the,
don't have to draw the positive one.
you don't actually, because everything was negative on this problem. And then your time, 1 second, 2 seconds, 3 seconds. So that's your which stone?
A.
Stone A. So
It
there's
goes
great.
from 0.
It goes from 0
Then it decreases.
after 1 second.
1 second, it's
It-
negative 9,8.
Now, did you draw it at 1 second, negative 9.8?
Yes, sir.
You actually did. It's not quite on those blockies, right?
Yes, sir.
Okay, so then that's great. Now you got to do stone B.
Okay. The same. The
Now,
gra-
stone B, here's the trick. Did stone B move from the beginning?
stone B.
Yeah.
Yeah. It wasn't like this, so yeah, so I did move it.
So when we dropped stone A, what was stone B doing?
It was, when we dropped stone A,
What was stone B doing? Any ideas? So after 2 seconds, we threw stone B down. So what was stone A doing before we threw it down?
stone A was at least.
No, stone A was dropping. There, you see it dropping. But stone B was only thrown down at 30 after 2 seconds. So for those first 2 seconds, what was stone B doing?
Wasn't it also at least?
Was it moving or was it stationary is the question.
Wasn't it stationary?
It was stationary. It hadn't been thrown yet. So stone B started at 0, but then what was its initial velocity? So it was 0, 0, and then suddenly is it plus 30 or minus 30?
Negative 30.
There you go. So then it suddenly goes to negative 30, and then does its thing.
It goes from -30.
And then, what does it do after 1 second? -30, -40, -50. So it starts at -30, but then it's -40, well, just 9.8 more, negative, and so on. So you've got to draw it the same way. Does that make sense?
Must I draw it on another?
No, it must be on the same graph. And so you must label that as graph A, stone A. Just put an A on the line.
On the line.
Yeah, just a capital A, that's the graph of A. Does that make sense to you? Great.
Isn't after 2 seconds? It's from 2.
Okay, so Jamie, how are you doing?
So I'm
You've
doing
got
my
your
time
axis. Now, just a thing here. When you do your axis, don't draw 0, 9,8 and so on.
Why not?
Do 0, 10, 20, 30, minus 20.
Do minus.
And then
Minus
look,
Estimate.
estimate where 9,8. You always have whole numbers on your axes.
But Sylvia just not said I must do 9,8.
No, you must put 10, 20, 30, 40, and then estimate where 9,8 is. Now, do you understand why, if you're estimating where 9,8 is, it's better to have a big spread out axis? Does that make sense? Because then I don't need an electron microscope to mark your work. So here you're going to put minus 10, minus 20, minus 30, minus 40,
I
right?
don't know how to plot the stuff, so.
Okay, well, get your axes first of all. Do you want to do it properly and spread it out? Okay, so put 0, minus 10, minus 20, minus 30. You got the whole page, minus 40. We'll kill a forest, and I'll give you another page. So let's just go all the way down. I don't know how far it goes, but make it nice and big. Now let's have a look at your one.
It's a mess.
And then-
So please don't put that in the camera. It's
Okay,
horrible.
so you've got your time on that axis, and it starts at 0 and it goes down, and there's stone B, is it?
Yes, sir.
Okay.
I'm playing, sir.
Okay, so here, first of all, the reason why I'm getting you guys to do these graphs is to see where you stand with graphs. And the answer is not very good, but by the time you've done this graph, you're going to be excellent and brilliant
For the other cross.
for the rest of the year. Okay, so this is where we pick up all the problems with your graph. Now let me point out, seeing as I'm going to do it, all the problems with your graph. No heading, correct velocity, meters per second. Time in seconds, great. I don't see 1, 2, 3, 4, 5. I couldn't mark it without that. I see here, I don't see any units there. So you've got to go 0. First of all, it's got to go 0, minus 10, minus 20, minus 30, minus 40, right? So everything's negative. So you've got to have, is that your
Yeah.
10 should be on that solid line. Your 20 should be on that solid line.
I used it in centimeters, like I use centimeters for the.
You don't need centimeters and variables.
You've got to use these. You can't measure your own thing. You've got to use these things. That's why we're giving you this graph paper. I'm not going to go and take my ruler and measure it.
Okay.
So it must go 10, 20, 30, or better. 0 there on the solid line, minus 10, 2 down, minus 20, 4 down, and so on. So it spreads it out.
Yes, sir.
That graph's got to be labeled graph A, that's got to be labeled graph B. Now, ladies, just listen to this thing. Again, I'm going to ask you the question I asked those guys. Stone A starts at time 0, but stone B does what for the first 2 seconds?
It's a stationary.
It is stationary. So stone B's got to do nothing for 2 seconds. It's got to be 0.
Yep.
So your line is going to be like that. Then suddenly stone B is 30. So then it's got to drop to 30 after 2 seconds.
Yep. So we're gonna start the graph somewhere
But
here.
stone B, how much time does it take stone B to go 1.88, no?
That's the time they put.
It takes 1.88.
So then it's going to be approximately D, and D is 30.
So what will stone B fall after 1 second? what will stone B's velocity be after 1 second? So it starts at 30, and at the third second, what will its velocity be?
1.
How do we work it out? Let's act it out. Stone B is going down at minus 30. After 1 second, it's going to be minus 40.
Oh yeah.
After another second, minus 50 approximately. So if it starts at minus 30, it's going to be minus nearly 40 or minus 39.8.
Oh, I know I could draw my graph now. Thank you, sir.
So all the things I'm looking for, velocity time graph, excellent. Time in seconds, excellent. 1, 2, 3, 4, 5, excellent. Naught, excellent. 10, 20, 30 meters per second, minus 10, minus 20, minus 30, 40. Axes are fine. You've got a naught and a naught. So I would give you 1, 2, 3, 4 marks already, and you haven't drawn a thing. If this was a graph that was going to.
Should I spread this out rather?
Okay, so there's your naught, right? So here's your naught. Now this y-axis, this x-axis, sorry, must go solid along the naught line.
Why so? But I need more.
You need to plot naught. Okay, so you need that not to be on the 10. Okay, you know, technically you're not incorrect. Technically you could have your axis there. So let's leave it like that. So correct. So stone A starts at naught. You get your mark there. But then what is stone A's velocity after 1 second? It's minus 10 or minus 9.8. So it's got to go this way down. And do you guys remember I said do this with your graph? That's the way it's always going to look, a velocity time graph, if upwards is positive. So now you've got your naught. So what is stone A going to do? So after 1 second, so at time naught, its velocity is naught. So plot it.
No, like so.
Exactly. After 1 second, its velocity is going to be negative or positive?
Negative.
Negative. How much?
Negative
9,8.
9,8. Okay, so now you got to find 9,8.
And then after 2 seconds, it's negative 19,6.
Exactly.
So how do you know how much seconds you must do?
The problem has got how many seconds in it? It only goes up to, no, it starts, goes 3,884. So you only have to draw 4 seconds in your axis.
Negative 29,3, and then then do I add in then like 2 seconds also, so it will be roundabout.
So you have taken it up to 4, which is great.
It will be roundabout here.
What? Your,
Comma 884, it will be roundabout there because
okay, so it will be 3,884, and then you got to.
884. And the line is right?
Now each 2 of those blockies is 0.1. Okay.
Yes, sir.
So 0.8 would be 16 blockies. That would be 0.8. And then 8 would be another. So you got to.
So but I still don't know how to do still B one.
But your stone A is looking good. Stone B. Let's see your stone A. Minus 10, minus 20. Your stone A is looking good. Just put an A on that line so I know that it's stone A.
Number 3 how much is 29?
It's better to put it on the line. A would be a point on somewhere.
26 comma something. Because it looks
Okay.
it's 26
All happy with that? Now stone. So that's correctish. Now stone
What do you
B.
mean ish so? What is 3? 3 seconds. And we have like 29.
You put your axis here. Technically you can do it, but let me tell you, people normally just put the axis on naught. So there's the correct place to put your axis. All the axes always, unless there's a reason for it, go through naught and naught. So won't you just take that axis and put it here? Does that make sense to you? So look at his, for example. He's got his axis on naught, but I still don't know what this line here is doing. Why are you not drawing your axis on the solid line?
With that, are they serious? Are they serious or are they just doing it? Thank you. They won't watch it.
Okay, but your graph was correct.
I know.
Your graph was correct. So it started at naught and then went 9.8 and then 19.6.
Yeah.
Now draw it here.
Now the 20 is not. But
On-
I need 0, so.
So you can still use 0, draw a line. You can still draw a line. You could put an X on the axis at 0.
And then so?
I'll show you. So just draw your line.
Now that's also
Okay, so you make a little cross where the plot is. There, that's it.
Is that all?
That's it. Now your next plot, and where's your time 1? And you put it below the line, not above the line.
With mass, any
It's just convention. We don't want the Jamie school of I'll do my own thing. There's rules. Okay, so you got your numbers there, you got your noughts. There must be another nought there for that one.
Another note. Where
That's the nought on the y-axis. We need a nought on the x-axis.
can they share notes? So?
No, they can't share a nought. And it must be below.
Why?
Everything's
Yeah.
must be
I've never
below.
seen a graph like this. So.
Okay, well, you haven't seen a correct graph before then. Okay, so there's your correct plot. Now, at 1 second, you've got to look for minus 9,8, which is just less than 10. Okay,
Greater.
so it's less.
Is it above? Yeah. Would it be there?
Just lend me your pencil. So it's going to be somewhere on this line,
No,
right?
sir. 1,884.
Okay. But
Somewhere there.
what will stone A's velocity be after 1 second? It will be negative 10. So plot it at negative 10. Well, it's actually 9.8. So just make it a little less than 10.
So I'm still here, so.
No, there's 1 second. So it's got to be there. Just let me do it for you. Okay, I'll do the first one for you. There's 1 second. I go down here. I look for 9,8 and it's there. So I plot it. You see what I did? Then my next one.
Each second.
Yeah.
Why? But
Then after 2 seconds, it's gonna be
so don't they want it of the stone? Stone.
no. This is stone A to start off with.
But stone A is 1,884.
You see, stone A just falls under the influence of gravity. So as we act it out, it's 9, it's 10. What's the next plot?
20.
Okay, draw it. But it's not quite 20. It's a little less than 20. Okay, so let's have a look at that one. So his graph does this. It starts at 30 or minus 30, it carries on at minus 30, and then it does the same increase in velocity.
Yes, sir.
So the question you've got to ask yourself is, for the first 2 seconds, was the stone B moving?
No, it is stationary.
So where are you going to put stationary? That's not stationary, that's moving. It's moving downwards at minus 30. But it's still moving downwards at minus 30 after 1 second, after 2 seconds. Stationary is naught.
So what am I going to do?
So you must have stone B is at naught. After 1 second, stone B is still at naught.
Oh, it's going to
After
start
another
here.
second, it's still at naught. But then it suddenly, then it vinnig goes down to 30. And then it should be parallel if you've drawn it correctly. Because then they both increase at the same rate,
Yes, sir.
9,8. Oh, I'm so glad I got you guys to do some graphs today. I wasn't even planning on it. Okay. So, you've got your stone A. Minus 10, 1. Perfect. Now, where's your stone B? For the first second, it's doing
Nothing.
Nothing. For the second, nothing. And then suddenly it does what? Suddenly its velocity is minus 30. And then it carries on increasing every second by the same as that. Can you draw that? We done?
So stone B.
So great, you got your stone A. Now you look at stone B
In a straight line.
at the start of the problem. Is it moving or not?
It's moving.
At the start of the problem. No. Stone A is, this is stone A, it's falling.
It mustn't go so.
But stone B is waiting for 2 seconds and then it's thrown down.
So I need to skip 2 seconds.
So what you've got to have is stone B for 1 second is on 0, for 2 seconds is on 0, and then suddenly it dives down to 30. Suddenly it dives down to 30, and then it carries on increasing in speed. So do you get it? So you've got to draw a plot along there, down to 30, and then follow that same parallel path. How are you guys doing?
So there's a problem here. So mine, don't look at mine first because mine was
Let's have a look at yours.
confused. Ask him 2
His one was good. I know his one is correct.
We saw
Okay,
that
so have a look at his one.
Yes, sir. No, so
the final velocity for A is minus 39, I think.
Was it?
Yes, but it must be 48, minus 48.
minus 48 there and
For A or B?
Both of them must be minus 48, but they're not the same.
Okay, but let's see. Let's see that you're correct. Okay, let's see. This one's totally correct, right? So after 1 second it was 10 approximately. After 2 seconds it was 20. After 3 seconds it was 30, and after 4 seconds it was nearly 40. Okay, if we work in 9,8, which yours is correct. It's not touching the exact axis. Perfect. Well done. Then your stone B is correct. For 2 seconds it did nothing. Then it suddenly jumped to 30. Then it increased by 9,8 the next second, and then it increased by 9,8 the next
But
second.
that's 4 seconds now.
And there's 4 seconds. And you need to write 1 second below the graph.
So
1,
must
2, 3, 4.
Must you go until 4 seconds? Must you go till 4 seconds?
Yeah, but you must write your on your axis below, you must write it not above, below.
Below.
It's always below the axis. Right, so that's 1, 2, 3, and 4. Okay. So what is your... You don't like the fact that they ended up at different velocities, do you? That bothers you. What do we know from the problem? They ended up at the same place at the same time.
Oh, not velocity.
Not the same velocity. The one had to be faster to catch up with the other.
So that's why.
Does that make sense? You guys, okay, you're doing well there. I mean, look at your graph. Okay, that's great. And then maybe if do you understand that, Sunil?
He did it right, but he skipped like 2.
But that's as long as now you must show that your graph B goes along that line and then drops. Do you see what I mean?
Must you draw like
You
this?
must draw it. Yeah.
Yeah, but
So draw it. Have you got a color or a highlighter or a black pen or something that you can just show the different colors? A red pen to show plot B. And then you must write on the A on the graph and B. Not so A. You draw it like this. Just leave me your pencil. So you write here. That is graph A, and that is graph B, and you draw it on the line. So I know which is which. And then you must give your graph a heading. And you must make sure you got your units, and well done. So Sunil, that's looking good. You see, Suneli was not stingy with space. Like you guys, you should go into postage stamp production. She's going into posters, which is great. I prefer that I don't have to use a magnifying glass to see. the answers.
So is it done correctly though?
Okay, so that's great. The only thing is just have that as well. You've got to draw that.
Yes, so I'm
section off.
gonna draw it now.
But
Like I have to-
otherwise, it starts at 30.
Yes.
Okay, yeah, here's another thing. You go 0, 10 on that line, 20 on that line. You don't put 9.8
Oh.
and 19.6.
I just doubled the 9.9.
Must you write the SI units here?
So you must just write on these solid lines 10, 20, 30, 40. That minus 9.8 is great what you've done. Leave it. But the actual values must be put in real solid 10
So I'll
increments.
just like this, or can I do this now?
So yours also going to go minus 10, minus 20, minus 30.
Is it T versus B?
You put V versus T graph.
Can I do this one? So put it in.
That's correct. And then you must draw an
Line,
axis as well and say it's a time, velocity time.
Because I can't draw with a
It's going to be a bit thick. Can't you draw in black pen maybe? Because it's correct, so you don't have to worry about it. Okay, just give me a heads up. What are we doing for time, guys? So that's perfect now. That's now here. Just have a look at these. You see, that's parallel. That's parallel. If it's not parallel, I know it's wrong. Because when it's falling freely, they always increase by 9.8 every second.
Yeah.
So that one, if it's increasing by 9.8, let's just check if it is. So that's 0, 1. That's 9.8. That's correct. So that should be the slope, and then this one should have the same slope as that one. So do you see why your two slopes must be the same? They must be 9.8. Do you see why, Michelle?
I don't know.
I'll tell you why. That's stone B, right? It started at 30, but after 1 second, it would be 40. Now look at your plot. It started at 2, but at 3 seconds, it should be nearly 40. It should be 39.8.
Yeah.
How's it?
Asking the questions.
We're doing a graph, question June's 2018. We're drawing graphs of those stones. Here's your... Happy with that? Are you ladies happy now? Let's have a look at yours. And as long as it looks parallel, that's great. And then, Anna, just make sure that you, in red pen or whatever, have your graph different colors and then put there, this is graph B. That's graph A. So you must label which graph is which, A and B.